Today we're going to solve equations by using square roots. So we look at example 2. I need to get x by itself. What am I going to do to try to get x by itself? We get rid of like the furthest thing away. What should we do to both sides of the equation? We're going to get the 31 to the other side so that we can isolate the x. Oh, I got to say something else before we do this. Sorry. This method that we're doing on quadratics does not work if the quadratic is in standard form and it has a middle term. It does not work if the quadratic is in standard form and there's a middle term. So if you see a quadratic that looks like this, you will not say, oh, I'm going to solve by square roots. You'll see that A, B, and C do not look like this. Either the BX term is missing, like in the first two, or there's something squared already in it with the x. So those are the kind that you would use this for. All right, so we're going to add 31 to both sides. We're going to get 4x squared equals 80. X is not by itself, so what do we do next? Yes. We're going to divide by 4. So get x squared equals 20, and we are trying to solve for x. You cannot divide by x to solve for x. You have to undo whatever was being done to the x. So being done to the x is a squared. How do I undo a squared? You square root. However, there's a rule that is not emphasized very much until now. That x squared definitely equals a positive number. If you square any number, if you multiply it by itself, it will always be positive. If I take negative 4 times negative 4, it equals positive 16. So what you don't know is if x was a negative number or a positive number before it was squared. You cannot look at that and say, oh, that was a negative number. You can't look at that and say that was definitely a positive number. You don't know that. So when you are solving and you do the square root, you have to say it could be positive or it could be negative. I don't know. So when you are solving the equation, I put this on my board right here. And it will stay on the board right here for a while. When you square root both sides of the equation, you also have to put a plus minus. When you put the square root in, you also include a plus minus. And you do it. Okay? So now we're going to say, what's the square root of x squared? Well, that's x. Equals plus minus. Do we know the square root of 20? Is it 4?
4.472.
Oh, yeah. So that's an approximation. That's an approximation. That's not an exact answer. In Algebra 1, they taught you how to simplify radicals that were irrational numbers and would give you horrible decimals like that. They taught you how to simplify them in Algebra 1. So you should know that 20 is the same thing as the square root of 4 times the square root of 5. How do I make 20? 4 times 5. How do I make square root of 20? Square root of 4 times square root of 5. That's a property from Algebra 1. And the reason why I picked 4 and 5 and not 2 and 10 is because 4 is a perfect square. So what is the square root of 4? 2. So my next step, I'm going to replace this 4 with a 2. And I'm running out of space, of course, because I forgot how much space I need. I have plus minus. I replace the 4 with just a 2. And then I square root of 5, I cannot replace. I'll leave it as square root of 5. So that's it, the 2 answers for x for that. And we're not doing x-intercepts, so you don't need to write order pairs, just solve them for x. Okay, next one, b. We're going to solve it for x using square root methods. What do I do first? Subtract the 9, so we're going to have 3x squared equals negative 9. Divide by 3. X squared equals negative 3. Now how do I get x by itself? Square root. But if I am square rooting both sides of the equation, not what my question is, I also have to put in a plus minus. Did you type that in your calculator?
You can't square root negative 3.
I know you can't. Did you type in your calculator?
Yeah.
And it said non-real?
Yes.
Okay, well that was what I was going to have you all do, Max, but you just blurred it out. Sorry. So Bradley's like, wait, he wanted to know the answer so bad. And he got so excited when he found out that's not a real answer. Yeah. So if you type square root of negative 3 in your calculator, which we aren't typing these in our calculator anyway because we're simplifying them and not finding a decimal. But if you type it in your calculator says error. That's not a real answer. You cannot take two negative numbers, multiply them together, and get a negative number. You cannot take two positive numbers, multiply them together, and get a negative number. There aren't two of the same number that equal negative 3. So this is not a real answer. Did you know that there are... Go off on a tangent for 1 second. Does anybody know anybody who's like an electrician? Or you know somebody who's an electrician? Yeah. Do you think you have to have a college degree to do being an electrician? No, you don't. You have to take some extra classes, like electrician classes, but like you don't have to have a degree to be an electrician. I don't think so. I think you could. I don't know. I haven't looked into it, but you don't have to go to a big 4-year college to be an electrician, and they make pretty good money. But what you do have to know is you do have to know how to take the square root of a negative number. Because when we build circuits, something happens. I haven't taken my classes, so I don't know. But something happens, and they end up having square root of negative numbers. You say, but that's not a real answer. It's not. It's imaginary. It's totally imaginary. So she's the one that ruined it?
Yes.
No, I'm just joking. I like to be the one to tell you that there are imaginary numbers. They're not real. They're called imaginary. And so just for this one right here, this is not a real answer. But in 3-2, that teeny little bit of 3-2 we're going to do today is going to be me showing you imaginary answers. But it has to do with real life scenarios and not college degree real life scenarios either. So it's it's basic stuff, but you have to know algebra 2 to do it. Okay, so we'll move on because that's not a real answer. I'll show you how to do that in a moment. For C, I'm leaving more extra room because C is going to take a little bit extra space. Just heads up. So C is set up a little bit differently than A and B. It has a fraction on the outside. That's the furthest thing out. So how do I cancel out that 2 best? What is its reciprocal? 5 over 2. We'll multiply both sides by 5 over 2. So on the left, I'm going to have x plus 3 squared. But on the right, in order to multiply 5 times 5 over 2, you have to put 5 over 1 and multiply straight across. You get 25 over 2. Then what is our next step? Get x by itself. Peel away those layers until you get all the way down to x. What's the outermost layer? Well, there's something outside the parentheses. So how do I get rid of squared? Square root. Both sides. But if I square root? Plus minus, thank you. So I have x plus 3 by itself equals plus or minus square root 25 halves. Still trying to get x by itself. I need to get rid of plus 3. How do I get rid of plus 3? Okay, when I rewrite this next step, we always put the subtractory in front of the plus minus, in front of the radical 25 over 2. When we have a square root term and we have a not square root term, we put the not square root term first. It's not wrong to have it last, it's just that's not how we write it. Okay? Now, this square root is not a perfect square. However, is there a square root in it? A perfect square root in 25 over 2. Do you see any perfect square roots in there? The 25 part. So there's a rule that you should have learned in Algebra 2. I'm going to move up here. You should have learned in Algebra 2 that says, in Algebra 1. This is Algebra 2. If you're dividing underneath the square root, you can actually do the square root of 25 over the square root of 2. You can divide them after you square root them. And if I do it that way, then I can rewrite this as 5 over square root 2. And then you all say, wait a minute, I think there's a rule from Algebra 1 that says I cannot do something you just did. Anybody remember that rule? Can't leave a square root in the denominator. For it to be simplified all the way, I'm not allowed to leave that radical in the denominator. I'm not allowed to leave the rat in the den. Okay? You're not allowed to change the value of it, but we can change the way it looks. So what I'm going to do is I'm going to multiply just this 5 over square root 2. I'm going to multiply it by a value of 1. If I multiply something by 1, it does not change that value. However, it's not going to look like 1. It's going to be in disguise. If I multiply it by square root of 2 over square root of 2, that is multiplying by 1. So I'm not changing the value. I'm just going to change the way it looks. So on top, when you multiply a number that's not a square root with a number that is a square root, they go together. 5 square root 2. On the bottom, if they are both square roots, you multiply the numbers together under the square root 4. Now, why did I do that? Because square root of 4 is not a square root anymore. It's just a 2. So we have negative 3 plus or minus 5 square root 2 over 2. Brother.
I have a question. 25 over 2 is 12.5. That's what we found into.
Not the square root of 12.5 because the square root of 12.5 technically has a radical in the denominator even as a fraction.
12.5 is not a fraction.
We don't leave decimals under square roots. Not in higher level mathematics. So don't do it that way.
But it seems simpler than this.
Exactly, but in higher level mathematics, fractions are way easier to deal with than decimals. But you're not there yet, so you can't tell the future like I can. I've already done it all, and it's hard. All right, so that's what we're going to do from section 3.1. Let's look at section 3.2. So section 3.2, I want you to find the front page at the bottom. There's a paragraph that says notes. You only need to read it right now. I'm just going to put something right above it. Okay, so square root of negative 3. Now I'm going to talk about what I started to talk about. That's not a real answer, but it is an imaginary answer. And because we needed a way to use this answer in mathematics so that we could do things like connect circuits to be an electrician, they made something up. They said, we need this. We've got to make something up so we can use it. So in this paragraph right here, the square root of negative 1 is an imaginary number. The square root of negative 1 is I, which stands for an imaginary number. That's what they made up. The square root of negative 1 is I. And it's a fancy, like, cursive I. The square root of negative 1 is I. Right? So what? Yes, you'll see I'll write it. So what we do right here is we say, is there any perfect square that goes into -3? Now there is. Square root of -1 is a perfect square that goes into 3, or -3. We multiply -1 by 3, and we get -3. -1 times 3 is -3. So then I ask you, what is the square root of -1? There was like 4 people. What is the square root of -1? Alright, the rest of you figure out the pattern here. What is the square root of -1? Okay. We'll have all day to wait. So I'm going to write I, and then square root 3. So the square root of 3 we still can't do anything with other than make it a horrible decimal that you have to round. But now we can take the square root of -1. So now flip it over. To the top, example 1. The square root of -25. I'm going to break that down to square root of 25 times the square root of -1. What's the square root of 25? Okay. What is the square root of -1? I. So the square root of -25 is 5i. 5 times I. Square root of -72. Is 72 a perfect square?
No.
Okay, it's not. So I'm going to pull out the -1 and the 72. And what is the square root of -1? I. You guys are lining out a little bit. Square root of 72, does that have a perfect square that goes into it? Yes or no?
Yes.
Yes or no? The answer is yes. I want to know the biggest perfect square that goes in. 9 is not the biggest, because 9 times what? It's like 9 times 8. But 8 has a perfect square in it still. It does. What's the biggest perfect square? 12 is not a perfect square. 12 does go in it, but not a perfect square.
36.
36. Excellent. And you know what? She was goofing around, not goofing, but she was like playing around with her calculator to figure it out, right? That's what everybody should have done. Unless you know all the factors of 72 off the top of your head. So that'll be 36 and 2, that makes 72. So now, what is the square root of 36? So the order that we write these answers is a number by itself, then the I, then the square root if there's any square root left over. So 6i square root 2. Do I need plus or minus with these? Why not? Because I didn't write it, so why not? Nope. Nope. Why did I say we need the plus or minus? Right, what were you doing that you weren't sure? What were you doing? We were square rooting because we were solving for x. When you yourself draw in the square root and it's not given to you, and you're the one that says, oh, I need to square root that, you draw it in, that's when you do the plus minus. This one's already given.
So anytime that you find the square root of a number like this, you write it down. So you use the square root of that number, you write it down. So it's not the answer that you get. It's just keep it down so you can't write it down.
Yes and yes. Let's do one more, and then ask me the question again, okay? Because I think I understood that. All right, this C question, we've got a -5 and it's outside. What operation is between -5 and that square root that's sitting there? That's multiplication. So the -5 is already on the outside. I'm just going to bring it down and multiply by whatever I'm getting when I break this down. -9 can break down to square root -1 and square root of 9. And you tell me, what is the square root of -1? I. What is the square root of 9? 3. So now I have this -5, this I, and this 3. And what operation is between all of that stuff? Multiplication, because you don't see any plus signs. So negative 15i would be our answer. That's all I'm teaching about imaginary today. You'll learn about more imaginary stuff tomorrow. We've got one more set of stuff to do, and that is something from 3-3. That won't be till tomorrow, but there might be a question in the homework that has an I in it, but it's not going to be like, do I over and over and over and over again. Okay, we won't do that till tomorrow. Okay, this says exploration. We don't have time to explore. We'll have time to, let's do it with the teacher. Okay, this says solve this by using square roots. But if you were listening earlier, I told you if it's in standard form and you have a BX term, you can't use square roots to solve it. I did that earlier. If it's in standard form, I know you're just playing around with that thing. Put it down. Yeah. I don't want you to lose out on this amazing education opportunity right now. This is the hardest stuff right now. Yeah. Okay. So if it's in standard form and you have a BX term, you cannot solve by square roots. What form is this in? Standard? Do I have a BX?
Yeah.
Oh no. But I'm telling you to solve by square roots. So what you have to do is you have to manipulate the equation so it's not that form. You get to manipulate it. And we're going to use factoring to do that. Yay! I want you to look at the x squared minus 16x plus 64. Trinomial, no GCF. I want you to factor that. Ignore the 100. I want you to factor x squared minus 16x plus 64. What signs? Both of them?
Yes.
Same sign because this is a plus sign. This says they're both minus. What goes in the first spot? X times x. So we just have to figure out the other numbers. What is it? 8 and 8. So is this factored all the way? Why not? Because they're exactly the same, so we write it as a perfect square. That sounds familiar, like we're about to use square roots. So if it's written as a perfect square, now we can use the square root method to solve for x. Okay, so it's written as a perfect square. So now we're combining together factoring and square root. So since I'm trying to get x by itself, squared is the outside thing, let square root both sides. But if I square root, what do I need to do? What do I have left over? X plus 8 equals plus minus 10. All right, well, then I'm going to subtract 8. And I'm going to put it in front of the plus minus. And we did the other ones. And then please tell me, can you guys add together a negative 8 plus a 10? Can you do that? Isn't it? Sorry, it's not a plus. Thank you. You're raising your hand. And I'm remembering that as I'm like, remembering the answers to the other plus. I just made a mistake. Sorry about that. It's supposed to be a minus 8. Yeah, my bad. Thanks for catching that. Okay, can we add together an 8 plus a 10? Yeah, they're like terms. We can add them together. Can we take 8 minus 10? Then do it. Both of them. We're going to find 2 different answers. So we just kind of combined factoring and square roots in one question. What I want you to do is numbers 1, 2, and 3. Pick one and try it. If you're super fast, you can try one more than one. I'll put the answers up in a moment. But at least one, And try it. See if you can combine the two things we've been doing. Follow the steps I just did. Pick 1, 2, or 3. Pick the easiest one. Pick the hardest one. Try one. You said, what do you multiply together to get to 64? Each of these two. And then when I multiply my outside and my inside back together, I get minus 8x, which add together to give me minus 6. So we're multiplying it back together once we get our numbers there. I think so. I don't have the signs, but I'm going to have to put it up somewhere around here. So as you're working, I put the answers up. Don't just look and copy it. Look after you've tried it and see that you did it right. If you got at least one of those, read the next question, try to figure it out. I'll get there in a moment. Square root of 1 is 1. That's a common mistake. First one. I got that one. No, that would only be square root of negative numbers. That would be it. So that's just square root of 1. That's the square root of 1. Yep. So that should be it. We haven't come back to the idea yet. We will. Also, the basic bracket goes after the equal sign, just to remember this. If you've tried at least one of them, please read the next question, because we're going to do that. 30, you didn't square root of 36. You just square root. Square root of 36, fine. That one should have been square root. It's underneath it. What times of something 37? Yeah, so that should be the next one. Is that a 3? So then you have to do 3 plus or minus 1. Look right up here. 3 plus or minus 1. So you have to do 3 plus 1 and 3 minus 1. So I took 3 and I added 1 and subtracted 1. That should be mine. Yep, I got that.
Oh, this is right.
Yes. Good job. Try some on the back. There's like a pretty one. So okay, I wrote my answers right now. Okay. I'm going to go on to example 2. Example 2 says, find the value of c that makes x squared plus 14x plus c a perfect square trinomial. So that means when I factor this, I'll have 2 of the exact same factors, which means I'll take it a step further and have something squared. We can start thinking through this. What signs will they be if I have 2 pluses? Okay, I know that. What should be in the first spot if I have an x squared up there? X and x. So now you have to figure out what will be in these places so that you get this. But it's actually not asking for that. It's asking what is going to be after you multiply it back out or like check your answer. What will be that C value? So if you can get to here, I know you can get to the C value. So I'm going to walk around. If you haven't gotten it yet or showed it to me and I said, yep, that's right, then show me it. And then try the next like 3 that are on the back. Yes, that's so good, yeah. Okay. Oh, you're one? Oh, you're two? How did you say yours? I'm going to see you multiply this back together. Well, that might help you figure out whatever. Yeah, try to match. This is when we boil it back together and put it okay, and then you like multiply it all back out. So if I were to boil it back together, and then outside, inside, makes what's on it. That's exactly. Hello. Hey, hi. Amanda? Do you want to get on canvas for your assignment or take a picture of it? I can do it. Okay. You're gonna need to watch the video. All right, so what did you guys think were in these lines here? We thought 7. So if I were to multiply these back together to figure out the C value, you would do 7 times 7 to get the C value, which is 49. And how did I get 7 originally? Where did that come from, this part? But I didn't add the 7x, I came up with the 7. So where did I come up with the 7? Magically hits me. Pythagorean square. Yeah. You looked at B, and then what did you do to get 7? You divided it by 2. That's what you did, because these were going to be exactly the same. So you took that B term, and you divided it by 2. That's how we got 7. How did we get 49? You took that answer, and you squared it. That's what you did. There's 3 more. I want you to find these 3 answers. Again, we took the middle term, we divided it by 2, and then took that answer and squared it. Well, this says same sign. And this says which sign it is. Let's see if we got that. That's the factory form. So now what is the C? Well, if you this looks right. If you multiply that together,
Square.
that's what it is. No, it's not 2. 1 plus 2. Negative 1 times negative 1. It's 1. This is not, we're not using a calculator, it's going to be a fraction. Can you do a fraction? Or do a fraction? It'll help you. You ever going to take the SAT? You know, you're going to go on the SAT. The SAT or the ACT? Oh, that's probably practice ACT. On the SAT, there's a non-calculator section.
We have to take that.
You might, depending on where you want to go.
Oh,
Not
fair
if I
enough.
want to go in the well, there's some that require both, but I thought this was less, not some. Yep, those are good. So, what you should be doing is you should say 8 divided by 2 squared is 4 squared is 16. This one you do negative 2 divided by 2, which is negative 1 squared, which is positive 1. All of these answers should be positive to make this a perfect square. This one we do negative 9 divided by 2, and then we square it. Oh no. Negative 9 does not divide by 2 evenly. Do not make it a decimal. How do you square a fraction? Yep, multiply top times top, bottom times bottom, you get 81 fourths.
Or you just get the decimal and calculate it. Or you just say 21.
I guarantee I did that faster than it took you to type it in the calculator. Plus I understood the math. Okay, last example we're doing today, actually, last stuff we're doing today is example 3. You're going to find out why we just did all that. Okay.
The number 6, like, I got 9. It's like negative.
What's 9 divided by 2? Not 3. That's very good. Somebody else did that too. Okay, we had to practice this stuff and the stuff on the front to be able to do something you did in geometry called complete the square. You did this in geometry. Everybody in geometry right now? Okay, so you haven't done it. Everybody else, you've done it in geometry. I don't know if you did it in Algebra 1 or not. So I'm going to take you through the steps of complete the square. Okay. It's something that happens in all these courses because it's, like, used a lot. Okay. So what we're going to do is we're going to solve this by square roots. But when you go to solve it by square roots, this is a bx term. So we have to manipulate it. If you go to factor and make it a perfect square, it doesn't work because 7 is not a perfect square. So we're going to manipulate it further. First thing I'm going to do is I'm going to move the 7 out of the way, get over there, get off to the other side. I'm going to move it, and when I rewrite it where the 7 was, I'm going to leave a space. So I'm going to rewrite it as x squared minus 10x space equal sign negative 7. This is how I can stay organized. You don't have to leave a space, but it might be less organized. Now we're going to do what's called complete the square. So since I'm completing the square, I like to make it obvious. That's what I'm doing and say, here's a square, I'm going to complete it. See, I drew a square, I'm going to complete that square. But if I add a square to one side of the equation, I have to add it to the other side of the equation as well. You can't just add a square to one side. Makes it not an equation anymore. So this is now the examples we just did right above it. What does C have to be to make this into a perfect square? So you're going to take your B term, the formula that I wrote at the top. You're going to take your B term, and you're going to take negative 10 divided by 2, which is negative 5, and then you square it, which is 25. Well, that is my square that goes on both sides of the equation. So I'm manipulating this equation to make it something that I can solve. Once I've done that, then on this side I've got x minus 5 times x minus 5 equals 18. So what I did was I factored this perfect square. The way that you guys have been factoring. I just did it really fast because I got to get this video done. And then from there, since they're exactly the same, we write it as x minus 5 squared. So our goal is to solve for x. Once I have it to this form where this entire side is squared, how can I solve for x? We can square root. But if I square root, So x minus 5 equals plus minus 18. I'm going to move that 5 over by adding 5 to both sides. So I'll have x equals 5 plus or minus square root 18. I forgot to ask you, is the square root of 18 a perfect square?
No.
No. But does it have one in it?
92.
So the 9 is a perfect square. So we are going to simplify that 9. So now I have x equals 5 plus or minus. Instead of square root of 18, I now have 3 square root 2. I cannot add 5 plus 3 because 3 is being multiplied by a radical, making these not like terms. So I cannot go any further. I will not have nice answers. Those are going to be my final answers. I can't even add them together. Not like terms. So you see how we used square root, which we went over today. We used finding the c value that we went over today. We used factoring that we went over last class. We're going to do one more example, the exact same thing, number 7. And I'll stop the video. I promise, you don't even have to do anything in last class and think about it, okay? Well, there's an assignment, but you don't have to start it. You can start it if you want. I'm sorry. You can start it if you want. Okay, so we're going to go do the exact same steps I just did. The first thing we want to do is say, can I go ahead and make this a perfect square? Is this factorable? And the answer is no. Just so you know, the answer is no. So I'm going to move that 8 away. Bye-bye. I'm going to leave a space when I rewrite it. So x squared minus 4x space equals negative 8. And in that space, I add a square. And I add it to both sides. And we're going to complete the square. We complete the square by taking the b term, negative 4, divided by 2, and squared. So negative 2 squared is negative 2 times negative 2 is 4. So that is the number that we add to both sides. That is how I manipulate that equation. So when I go to factor this equation, it is now x minus 2 times x minus 2 equals negative 4. See how I manipulated it? So now it is a perfect square. X minus 2 squared equals negative 4. Once you get to the step where you have something totally squared here, how can we undo it? Square root? And if I square root, those are buttons. X minus 2 equals plus or minus square root negative 4. Anybody want to tell me what happens next? Oh, all kinds of things. So I heard add 2. We'll do that next. That's fine. I did hear other things in there that are also correct. So now I have x equals 2 plus or minus square root negative 4i. Oh, yeah, whoops. Okay, we'll part of that. Negative 4. All right, now what's the other thing you want to yell at me? Well, we're going to have an I. Yeah, we want to look at this as being square root of negative 1 and square root of 4. So I have x equals 2 plus or minus. What is the square root of negative 1? And what is the square root of 4?
2.
So do I write that I2?
2i.
2i. These are not like terms because one has an I, one does not. You cannot add them together. You leave it. I'm going to put up your assignment. It is also written on Canvas. It is in the book. It is messy because I'm messy. This is supposed to be 20. People had trouble. 20. And then we're gonna talk for 10 minutes.